All right, let's look at number 7 on the notes. Maple Street, Oak Drive, and West Avenue intersect to form a triangular piece of land. The angle formed by Maple Street and Oak Drive is 79. We're going to assume there's a degree symbol right there. So we know that Maple Street and Oak Drive intersect, and there's a 79-degree angle right there. So then that means that West Avenue is our other side over here. So let's see what else they tell us. If the Maple Street section of the triangle is 390 feet, so that side of our triangle is 390, and the Oak Drive section is 250. What is the length of the West Avenue section? So obviously this is law of cosines because we have the angle between two legs of the triangle. So we are looking for x squared is equal to 390 squared plus 250 squared minus 2 times 390 times 250 times the cosine of that included angle is 79. This one is just plug it all in and take the square root. Now this number is going to be a little bit bigger since we're dealing with 390 feet, 250 feet. We're going to get 421.2 feet. Let's make sure that that seems to make sense. 79 degrees, that could be the biggest angle in the triangle because that's almost 80, so that leaves us 100 for the other two, which would mean that the other two angles would definitely be smaller than the 79 degrees. So 421 is our longest side, 79 could be or should be the largest angle in this case. Okay, let's look at number 8. Jack and Tom start at a tree. So let's say we've got a tree right here, and they begin running apart with an angle of 23 degrees between them. So 23 degrees is that angle right there. Jack runs 50 meters. Tom runs 38 meters. It really doesn't matter which side you put that on. It's going to be the same difference either way. The question is find the distance between them. So my triangle's a little, I should probably make that side a little bit longer since it's 50 meters versus 38 meters. So we are looking for this distance right here between, I'm going to label that with the J and label that with the T, not to be confused with the tree down here. It wants the distance between Jack and Tom after they have run. So same deal as number 8. We have 2 legs in the included angle. Square root that value. So the distance is approximately 21.1 meters apart. Okay, last one, we're going to find an angle here. 2 radar stations 2.5 miles apart are tracking an airplane. I'm going to read a little bit more of the problem before I try and set this up because I'm not entirely sure. That doesn't give me a whole lot of information right there. Then it says the straight line distance. That just means if you go in a straight line from station A to the plane, shortest distance there is 7 miles. The straight line distance between station B and the plane is 9 miles. What is the angle of elevation from station B? So we've got, this is kind of a scenario where we're looking at something up in the air. So we've got station A, we've got station B, and we have a plane up here in the air. So from station A to to the plane is 7 miles. From station B to the plane is 9 miles, and the distance between A and B is 2.5 miles. And yes, my picture is very much not to scale, but that's okay. The question is, what's the angle of elevation from station B to the plane? So the angle of elevation is always the angle that is formed with a horizontal. So it's kind of like, imagine this, you're looking straight ahead, and then you either look up, that's elevation, to whatever object you're talking about, or you look down, that's an angle of depression to what you're talking about. So we're looking for that angle down there at B. So that means that we need to use 7 by itself, and 2.5 squared plus 9 squared are going to be together, because we're looking for the cosine of angle B, and 7 is the length across from that. So 2.5 squared plus 81 is 87.25. And that's 45 cosine B. So we're going to subtract and then divide. We're going to get 17 over 20 is equal to the cosine of B. So we'll do the inverse cosine. (17 over 20 is angle B, so that is 31.8 degrees, approximately. 31.8 degrees. The angle of elevation at A, would that be greater or less? The angle of elevation at angle A be greater or less than 31.8 degrees? Greater, because side A is bigger than side B. So this would be a bigger angle right here, and angle P would be our smallest angle. We're not going to, well, actually, you know what? Let's add to that. Let's find those, okay? Let's find those, because I do want to do an example where you have to continue from that point. So here's what I was talking about. At this point, you have enough information to use the law of sines. You could repeat the law of cosines, but it's a lot more involved than the law of sines. So why not just go ahead and use the law of sines to find that angle at A? So cross multiply and divide by the 7. So that number is approximately the sine of angle A. So we want to do the inverse of that number. So 42.6 degrees is approximately angle A. Now, is this making sense? If we subtract 42.6 and 31.8, we get 105.6 degrees for this angle up here at the plane. That's not making sense. That is not making sense. So we need to back up a little bit. We need to go back to this 31.8, and we need to find its supplement. Okay. Well, that's not going to work either. That's going to be too big. Are my units the same? Yeah, they are.